Yes, welcome to my series Mathematics for Senior Secondary. We are still on the topic completing the square, or we are still on the topic solving quadratic equation. And in the last video, I explained the basics of the foundation of completing the square. So now we want to see how we can apply the completing the square to solving problem. So the first one, I explained the basic concept. In this place, we'll see how to use completing the square to solve a problem. So you still follow the same procedure, given that we have x squared plus 5x plus 6 equals to 0. So we want to make this a complete square. How can we make it a complete square? Step number one, I write it just like the previous expression, such that I only have this on one side. So I have x squared plus 5x is equals to negative 6. So I can make this side a complete square. So how do I make it complete square? Do you remember? Yes, x squared plus 5x. I pick the coefficient of this, which is 5. I multiply the 5 by 1 over 2. I square it, which is equals to 5 over 2 square. Remember, it's plus 5. So I have what next? I have plus 5 over 2 square. So whatsoever I add to left hand side, I must add to right hand side because it's an equation. So plus 5 over 2 square. So I factorize the left hand. To factorize it, I have x plus 5 over 2 all square is equals to negative 6 plus 25 all over 4, which this gives 1 over 4. So we have x plus 5 over 2 square is equals to 1 over 4. So from here we can find the square root of both sides. This is the reason why we were using completing the square. So we have x plus 5 over 2 is equals to plus or minus 1 over 2. So from this place we have our x equals to plus 1 over 2 minus 5 over 2, or x is equals to minus 1 over 2 minus 5 over 2. So this gives us minus 4 over 2, which is equals to minus 2, or this gives us minus 6 over 2, which is equals to minus 3. So we got the same as the previous solution we had. S is equals to negative 2, or s equals to negative 3. So let's take one more example when we have 2x squared minus x minus 3 equals to 0. So we want to apply the same completing the square. This is example 2. Step number 1, we want to write it the same approach, just like we used in the previous example. So step number 1, we take this guy, we take him to this place. So what do we have? We have 2x squared minus minus x equals to 3. Then we ensure that this one becomes 1. We have 2x squared minus x equals to 3. So we have x squared minus 1 all over 2x is equals to 3 over 2. So we have this one in the form. We need to convert it to a square. So to make it a square, perfect square, we have minus 1 all over 2. We multiply it by 1 over 2. The result we square it, and this is minus 1 over 4 square. Do you get it? So we add it to both sides because it's an equation. So I have x squared, or better still, I factorize straight x minus 1 over 4 whole square is equals to 3 over 2 plus whatever you add to the left hand, you add it to the right hand, minus 1 over 4 square, which is equals to 3 over 2 plus 1 over 16. And if we solve this properly, we see that the left hand side will be equals to the right hand side, and the right hand side will give us 3 over 2 plus 1 over 16 is equals to LCM 16. Here you have 24 plus 1, which is equals to 25 all over 16. So we have x minus 1 over 4 whole square is equals to 25 over 16. Since this is a square, we take square root of both sides. So what do we have? We have x minus 1 over 4 is equals to plus or minus 5 over 4. So from this place, what are we going to do? We split it, so we have x is equals to plus 5 over 4 plus 1 over 4, or minus 5 over 4 plus 1 over 4. So when we solve this, here we have 6 over 4, which is equal to 3 over 2. Or here we have what? Minus 4 over 4, which is equal to minus 1. So we can say for sure that s is equals to 3 over 2, or s is equals to minus 1. Final answer. So please, thank you for watching. Please subscribe, press the notification button if you have not click, so that you can see our video, like and share. Thank you. Once again, my name is Obafemi Omoni Raymond John. Thank you.